ready to turn your cameras on. You're going to need to turn your cameras on so I can see. Get those whiteboards ready. Get ready to turn your cameras on. You're going to need to turn your camera. All right. And okay, so again, this question says, Gloria rode her bicycle 0 and 75/100 of a mile in the morning and 1 and 10/100 miles in the afternoon. How many miles did Gloria ride in all? Solve this problem in any way you choose. So I'm really interested. I'm hoping some people drew a model or some sort to do this. All right. So let's see those answers. Let me see those whiteboards in 3, 2, 1. Showdown. Showdown. Let's see. Okay, I'm seeing a lot of the standard algorithm. Okay, I'm seeing a lot of the standard algorithm. Let's see, what else do we have? Okay. Okay, Riley, Keon, and Edwin, where's your whiteboards? Okay, thank you guys. Thank you, everybody. Thank you, everybody. I saw not really anybody had a model, but that's okay. Okay, everybody who participated and showed me their whiteboards getting a dojo point. Thank you. So let's take a look at this problem. Gloria rode her bicycle 0 and 75/100 of a mile in the morning and 1 and 10/100 miles in the afternoon. How many miles did Gloria ride in all? So I would like to show this using a model. Okay, so I'm going to use a model here. Let me get okay. Ooh. Let's see if I can do this. Does that work? That kind of works. Okay. So here I have a model of hundredths grids. Okay. Here I have a model of hundredths grids. It is too dark. Hang on. Okay, so I've got some hundredths grids here. And I am going to shade in to represent this problem. I'm going to shade in these hundredths grids to represent this problem. So I'm going to take my dry erase marker and I'm going to first shade in the first number, which is 75/100 of a mile. So when we look at these hundredths grids, I want you all to think of them. Okay, let me see if there's a better way to do this. Let's try this. Miss Brown said she does this in her class. Let's see. Can we kind of see that? Okay, you can kind of see that now. So I'm going to start by shading in some hundredths. So on this grid, we're going to think of one of these big squares. This is one whole. This is one whole, okay? And this is, we know that this has 100 squares in it because there are 10 in each row and 10 in each column. Okay, so there's 100 squares in this grid. So that would be 100 hundredths or one whole. So if each of these little squares represents 100th, well, each of these columns is going to represent 1/10. Okay, so there's 1/10. I'm trying to shade in 75 hundredths. So there's 7 in the tenths place. and there's a 5 in the hundredths place. So I'm going to shade in 7/10. So here's 2, 3, 4, 5, 6, 7/10. Okay, so that's 70 hundredths or 7/10. And then I have to shade in 5 hundredths. So I'm going to shade in 5 of these hundredths squares. So we got 1, 2, 3, 4, 5. And now, believe it or not, this represents 0 and 75. Oh, that's a backwards 5, isn't it? Right? Yeah. 75 hundredths. 0 and 75 hundredths. Okay. So now I'm going to take a different marker and I'm going to shade in the next number, which in this problem, the next number is 1 and 10 hundredths. So here's the tricky part. I have to now shade in 1 whole and 10 hundredths. Oof. Well, that can get a little confusing. So I'm going to start by thinking about it as it's not 1 whole and 10 hundredths. I'm going to think of it as 110 hundredths. So I'm going to shade in, here's 5 right here. We'll keep that 5 in mind. But here's 10. So if I skip count by tens, I've got 5 plus 10 is 15, plus 10 more is 25 hundredths, plus 10 more is 35 hundredths, plus 10 more is 45 hundredths, 55 hundredths, 65 hundredths, 75 hundredths, 85 hundredths, 95 hundredths. Okay, and this is where it gets tricky. So 95 hundredths, and then plus 5 more makes 1 whole. So I've gone from here, I've added 100 hundredths, so 1 whole, and then I have to have 10 more hundredths. So here's 5, 10 more hundredths. So this is representing the addition problem of 0 and 75 hundredths plus 1 and 10 hundredths using a grid. And using this grid, I can do addition, I can do subtraction, I can do so many things with these hundredths grids, and it can make it so much simpler. Okay, I just have to count the squares or the columns. So each square represents 1/100th, each column represents 1/10. That is how I can show addition using a model like a hundredths grid. Let's try another one. So here's what we need to know. Here is what is really important. You all are going to be getting, oh, okay. Can everybody, I just need everybody's attention real quick. So just pause what you're doing. We're keeping math in mind, but I am going to give an announcement. So I sent a dojo message home on Friday. Nope, Sunday. I sent a dojo message home on Sunday. Okay. And I sent, I also posted it on the class story that there is a pickup day today for materials. So if your parents come to the school sometime before the very end of the day, they need to come and pick up a bag, a plastic baggie of materials for you. In that bag, you're going to get the next copy of Storyworks. Hang on. This is what's coming in your bags. You're getting a cute little eraser from me. You're getting a little bookmark from me. And then you're also going to get Post-it notes. You're going to get a book called Blood on the River. You're going to get the next copy of Storyworks that we'll use for reading. And you're going to get a couple of worksheets. Now, these worksheets, it's very important that everybody's paying attention, okay? Very important. So Yes, you'll get your Storyworks, you'll get a book, you'll get some Post-it notes because we're going to do a book study. But then those plastic sleeves, those like plasticky sleeves that you all got that had a piece of paper in them that we gave you to be like a whiteboard, it's very important that you still have those. If you don't still have those, that's okay. The big plastic baggies, the big plastic baggies can also work as a makeshift whiteboard, okay? If you would like, I can try to get another plastic sleeve for you, but you have to ask. You've got to reach out to me and let me know. The plastic baggie can also work as a sleeve, but you're gonna get one of these. So this is a model of characterization activities, okay? So, you know, we've got our thoughts, our words, our feelings, choices, our actions. Okay, so this is a graphic organizer, so you never have to draw another one on your own. You can put this in your plastic sleeve or your plastic bag, right? And then you can write on the plastic bag or the plastic sleeve, and this becomes something that you can use over and over and over again. So do not, this is very important, do not write on any of the papers that are coming in your bags. Do not write on them with pen or pencil or anything. They're coming home so that they can go into a plastic sleeve of some sort to be used as a dry erase tool. Just like this hundredths chart that I just used. It's in a plastic sleeve so that I can erase it and use it again. You're also getting some math materials. These are very important because we don't know exactly how long we're going to be online. I have enough of these things for my whole class, but you all aren't here in person. So you can't use the ones that I already have made. So we're sending home papers for you to have your own little packet of dry erase math materials, okay? So this one, you're gonna get this one. It's got a place value chart. It's got a place value chart that'll really help. You'll really need that. It's got this, so it shows tenths in the columns. It shows hundredths, just like what we just used. And then there's also a version of it that has thousandths. Okay, this will be very important. So make sure you have this. And then it's got some other hundredths grids. It's got a standard algorithm thing this will help you line up things beautifully when we're working on multiplication. It's got this for division. So you're not going to write on any of these papers. You're not going to throw away any of these papers because during math and during reading, I'll say things like, get your character organizer out, or I'll say, get out your division standard algorithm paper, and you're going to have this in your plastic sleeve ready to write on with a dry erase marker. Keep these, do not throw them away. Everything coming home in this plastic bag is important for school. Give me a thumbs up if you understand how important the things are that are coming home today. Yeah? Okay. If you or your parents cannot come to school before 3 o'clock to get your materials, I will either make separate arrangements with your parents if you're out of town or something like that, or I will be delivering these items today. So if your parents can't make it to school today, expect me at your house this afternoon, okay? I'll be showing up at your door with these materials if your parents can't make it to school today to pick up your materials. Okay, I saw some hands, so I'll take these questions and then it's right back to math. Okay, Graham, go ahead.
So we're out of town and we'll be back until Monday.
You'll be back on Monday?
We'll be back Sunday, but we'll
okay.
Yeah.
So will you be here at school on Monday?
Yes.
Okay. Okay, good deal. Then if your parents can come get these on Monday, that'd be great.
Okay.
Okay. Yeah, other questions? Savannah, go ahead.
My mom wouldn't be able to pick it up because her lunch break, she comes home for her lunch break and that's the only time she would have. But she has a short lunch break, so she wouldn't be able to come pick it up in that time.
Okay, that's fine. Yours will just be one that I'm gonna have to deliver this afternoon, okay? Yeah, and that goes for everybody else. Anybody else whose parent has work and they can't come, yeah, you can come pick them up during recess. But anybody whose parents can't make it to pick it up, I will come. I've got all of your addresses here on a nice little sheet that I can just boom, 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 come drop them off at your houses. I visited Jackson and Gus not too long ago to drop off those science packets. So I don't mind to make these errands. But if your parents can come pick this up, that'd be great, because it'll make my job a little less long. Yes, Chloe?
My parents, I don't think that they can come because like we share a car and we can't like.
That's okay. It doesn't matter what the reason is. It's fine. If they can't come, that's fine. I'll just, when I go up at the end of the day to see what bags are left, that's who I'll deliver to. Okay. All right. If your parents can't come, that's fine. That is totally fine. All right, guys. Thank you all for listening. Sorry about that. I just wanted to make sure that everybody knew what was happening, because you will be getting, I wish that you already had these because I would love for you all to practice this addition and subtraction. But you all can always practice this tomorrow using these. So anyway, but let's talk about it. Let's really get into it. Because there will be questions on your test, there will be questions on your Practice Buddy and Quick Check that have these graphs. So I just need you all to understand that. Okay. So when we're adding and subtracting decimals using hundredths grids, the large square, so one big square, it's going to have the thick border around it. Okay, one big square, that is going to be equal to one whole. So what is, you don't have to unmute, but go ahead and say it out loud to yourself. What is one big square equal to? One whole. You need to remember that, okay? Because it doesn't matter what the square looks like. If the square just has the columns for tenths, if it has the hundredths, or if it has all these teeny tiny little thousandths. Do you see that? Do you see that? How there's 10 thousandths inside 1/100th square. Okay, it doesn't matter. The whole thing is equal to one whole. Keep that in mind. Keep that in mind. So it's all equal to one whole, or 10 tenths, or 100 hundredths, or 1,000 thousandths. Okay, one square is equal to one whole. Let's keep it moving. There are 10 columns and 10 rows for a total of 100 parts, okay? And each tiny square part represents 1/100th or 1/100th, okay? So this column is equal to 1/10. This tiny green square is equal to 1/100th. And if I split them up, so that tiny square is equal to 1/100th, but this tiny little rectangle inside the 100th, what would that be equal to? This teeny tiny square inside the 100th, what would that be equal to? Who can tell me? Who can tell me what that teeny tiny square would be equal to? Lila? Nope, nope, Keon. The columns are equal to tenths. So Lila, what do you think?
1,000.
Yes, yes. So the column is equal to 1/10, the little square is equal to 1/100th, and the teeny tiny rectangle inside that 100th is equal to 1,000. We will use that as we go and learn more about these squares. Okay, so if I had 5 of these tiny squares shaded in, that would be equal to 5 tenths, 5 hundredths, 0.05. Okay, so if I had 5 of them shaded in, that would be equal to 0.05. So what if I did this? I need you all to pay real close attention. What if I did this? What if I said, okay, now I'm going to do this. Okay. Okay, so what have I done? I've shaded in 5 more. So what does this represent now? I've got 0 and 5/100ths plus, I've got 0 and 5/100ths plus 0 and 5/100ths. Just from looking at it, what is going to be the answer to this problem? What is one column equal to, Gus?
One column is equal to 1/10.
1/10.
one.
So 5/100ths plus
Oh,
5/100. 5/100ths plus 5/100ths is equal to 10/100ths or 1/10. 5/100ths plus 5/100ths is equal to 10/100ths or 1/10, because there are 10/100ths in a column and each column is equal to 1/10. Okay, let's try another one. Okay, I want you to get your whiteboards out this time and you're going to help me with this addition problem. Okay, you're going to help me with this addition problem. So get those whiteboards out and ready to go. We're going to show down. Let's do it. Here we go. So 10 of these squares, like we just learned, is equal to 1/10, right? It's equal to 10/100ths or 1/10. Okay, so one column is equal to 10/100ths or 1/10. The reason it's equal to 1/10 is because there are 10 of them in a whole. Okay, so here we have 1/10 plus. All right, guys, so here's what I'm going to shade in. Here's what I'm shading in. All right, let's see who can figure out the addition problem here. What did I do here? How many did I add? I've got 1/10 plus. How many did I shade in there? Write it on your whiteboard. Write what you think I added on the whiteboard. What do we think here? How many hundredths did I shade in? Don't show me yet. Don't show me yet. Actually, Lila, let's look at yours. Put yours up to the screen again, Lila. Okay, everybody look at Lila's. Tell me what went wrong here? What went wrong here? She wrote 1/10 plus 7/10. Did I show 1/10 plus 7/10 on here? Can anybody help me find what's wrong here? It's not 7/10. Savannah?
It wouldn't be 7/10. It would be 7/100.
That's right. Let me see those whiteboards, please. Let me see those whiteboards, please. Let's show down. Let me see. Let me see what that addition sentence looks like. Okay. Let me see those whiteboards. Let me see those whiteboards. Fatima, Mateo, Maggie, Dom, Edwin, Riley. Let's see those whiteboards. Okay. So yeah, guys, well, hang on, Lila, you added a 0 on the end, or wait, no, somebody put a 0 on the end. Who was it? Somebody added a 0 on the end, and that made it 70/100ths. So we want 7/100ths. So in order for it to be 7/100ths, you have to write it with a 7 in the hundredths place. So if I write it with a 7 in the hundredths place, what's going to go in the tenths place? A 0. So 0.07. That's how you write 7/100ths. Okay. There we go. And so when I add, this would equal 17. It would equal 17/100ths because I've got 10/100ths here in the column, and then I've got 11, 12, 13, 14, 15, 16, 17 in all. So that's how I would add that problem. Okay, let's look at the next slide. Oops. Okay, oh dear. This shows 14 hundredths. This one shows 14 hundredths. I know that because here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know that 10 are in a column. Okay, 11, 12, 13, 14. So if I count up all my squares, that's 14 hundredths because each square is equal to 100. So that's 14 hundredths. Okay, what if I did this? What if I did this? Uh-oh, what did I do there? What do you think this could represent? What do you think this could represent in a model? What I just did. What do you think that could represent in our model? What do you think? What could this represent? Xing out some of the hundredths. What do you think that's going to represent? Dom, what do you think? Uh-oh, Dom, you got to unmute.
That it means there's two different numbers.
Not quite, not quite. If I am deleting some, if I'm Xing out some of the hundredths, what is that doing? What is that doing? Instead of adding, yes, Dom, I'm subtracting. I'm subtracting. So what am I subtracting here? What am I subtracting here? I X'd out 1, 2, 3, 4. I X'd out 4. What did I subtract, Riley?
You subtracted the 400.
I subtracted 4 hundredths there. Very good. How would I write 4 hundredths? Well, behind the decimal, we have the tenths place and then the hundredths place. So if I subtract 4 hundredths, it would be in the hundredths place, and there would need to be a 0 here in the tenths place. So I had 14 hundredths. I took away 1, 2, 3, 4 of them by Xing them out. So what is my answer going to be here? What do I have left over here? What do I have left over here just from looking at the graph? Hayden, can you tell us what my answer is going to be? What is my answer going to be? How many do I have left? What is one column equal to? Who can help me with this one? All right, I see it on some boards. I see it on some boards. So what's left over after I've deleted these, right? I've erased them, I've subtracted them. Okay, what's left over is one column or 1/10. Okay, you could also count the hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what's left over is 10 hundredths or 1/10. That's what's left over after I have 14 hundredths minus 4 hundredths. I get 1/10 or 10 hundredths left over. Okay, guys. So, oh, I have the pen out still. Okay, so here's an example problem right here. This is an example problem right here. It's a little bit crazy. So this is modeling. This is modeling the problem of 14 hundredths. Here's 10, 11, 12, 13, 14, plus 33 hundredths. Okay, plus 33 hundredths. So to add 33, we've got to start shading in the remainder of the column. So we've got 14 and then we have to add 33. So here's 1, 2, 3, 4, 5, 6. Okay, so I've added 6 hundredths. I know each column is worth 1/10 or 10 hundredths. So here's 6 plus 10 more is 16, plus 10 more is 26. And then I just shade in hundredths till I get to 33. So 27, 28, 29, 30, 31, 32, 33. So this is now showing the problem 14 hundredths plus 33 hundredths, 33 orange squares. Okay, and then to get my answer, I just see how many are in all. So I count my tenths first. We've got 1, 2, 3, 4 tenths. And then how many are in this column? 1, 2, 3, 4, 5, 6, 7. So my answer should be 47 hundredths. My answer should be 47 hundredths. Here's another problem that's being modeled. So here we have, let's count the tenths. 1, 2, 3 tenths. So that's 30 hundredths, 31, 32, 33, 34, 35. So this is modeling 35 hundredths plus, what's over here? Well, there's quite a lot over here. I am going to start by, let's see, so we're adding 83 hundredths here. We're adding 83 hundredths. So I know I've got 35. So this is going to be 5. 1, 2, 3, 4, 5. Then I add my 5 hundredths, and then I'll add the tenths. So here's 1. So that makes 15. 25 plus 10 more, 35 plus 10 more, 45, 55, 65, 75, and then 76, 77, 78, 79, 80, 81, 82, 83. So this shows 35 hundredths plus 83 hundredths. Okay, you can count your tenths and hundredths, or you can just count the squares if that's easier. Just count the hundredths if that's easier. Okay, and you get, since there is now one whole square, what's going to be in my ones place in this answer? There's not going to be a 0 in the ones place. There's going to be a 1 in the ones place this time. And then whatever's left over is what's behind the decimal. So I've got one whole, and that's a tenth. So that's 10, 11, 12, 13, 14, 15, 16, 17, 18. So my answer is one whole and 18 hundredths. Okay, guys. So then subtracting. Here's another subtraction problem, okay? So here we've got all of this green shaded in. We've got all of this green shaded in. It shows one whole and 4 tenths, because I can count the columns. I've got 1, 2, 3, 4 columns shaded in. Okay, and it's subtracting 8 tenths. So our problem here is 1 and 4 tenths minus 8 tenths. So I've shaded in 1 and 4 tenths, and now we just work on exiting out some tenths. So 1, 2, 3, 4, 5, 6, 7, 8. I've scribbled all of those out. Then what's left over? That is your answer. So how many tenths do we have left? Look, count the columns, 10, 20, 30, 40, 50, 60. There's 6 columns left. So my answer here, what's left over, is 6 tenths. That's the answer to my subtraction problem. Whew. I really wish you all had the models so that you all could model some problems along with me, but you will have them soon. So right now, let's just work on our practice buddy. Okay, so you're going to go work on your practice buddy. Okay, so it is 2-3 practice buddy. Okay, in your math website. So why don't you all pull that up and start working on that. I'm going to make a breakout room. Oh, we are missing some people. I'm going to make a breakout room, and anybody who wants help on the practice buddy can come to the breakout room, okay, with me. Okay. Who are we missing right now? If you want help on the practice buddy, come to the breakout room. Hey guys. So, those of you who are in here, if you have not finished your practice buddy, you can keep working on it. But I'm gonna send everybody who has finished your practice buddy, you're gonna go work on some problems with Mr. Newsome in the breakout room, okay? So those of you who have finished your practice buddy, you're gonna go to the breakout room now to work on some problems with Mr. Newsome. So go ahead and go. Go ahead and go. So that would be Gus, Riley, Maggie, and Chloe. So Riley, Chloe, and Maggie, you should be going to the breakout room with Mr. Newsome. Everybody else who's still in here can ask for help. I can help you all. I know number 3 is kind of hard on the practice buddy. Number 3 is kind of a hard one. So, hold up. Where did Dom go? And Savannah. Okay, so let's take a look at your problems on the practice buddy. Number three is a tricky one because it wants you to tell what the expression is, what the subtraction problem is. That's what it's asking for. So what you're going to do is you're going to count, you're going to figure out what the original number was. You're going to figure out what the starting number is, the whole that you're taking away from, okay? You're going to figure out that, and then you're going to subtract whatever got X'd out, okay? And then you're not going to solve it. You don't need to write an answer. You just need to write that subtraction sentence. Are they done? Had a bunch of people just go. Okay. All right, good deal. All right. So does anybody need help solving that one right now? Does anybody need help solving one? I can help you work through it. Lila? Okay. All right, Lila. Oh, did you finish? No? Okay.
I need help on number 2.
Number 2. Okay. What does yours say for number 2? What's the problem?
It's 1,360 hundredths minus 38 hundredths.
Oh, so it's 1 and it's a whole number?
Yes.
1. So all you have to do is you've got to figure out what's left over. So whatever didn't get X'd out, that's your answer. That's what's left over after the subtraction problem. You just have to count how many columns, that's the tenths, and then how many hundredths, the little squares, are left over after you subtracted. So that's just whatever doesn't have, whatever's not X'd out.
I need help on number 3.
Okay, Edwin. So what does yours say for number 3? Like, what does yours look like? Okay. Does yours look like mine, Edwin? Okay, yours looks pretty similar to mine. Okay, so Edwin, everybody else can just minimize the screen since Edwin is sharing. You don't need to Y'all don't need to look at it. Y'all can just minimize the screen and go back to your practice. But Edwin, so you're going to start out by counting what the starting number is. What did you start out with before things started to get X'd out? So you have one whole square shaded in. So what does that count as? That counts as one whole.
100,
So
like 100, like a 1 whole.
100 hundredths or one whole. So a 1 in the ones place. Okay, and then you have to have your decimal after the ones place, right? Okay, so how many columns were shaded in? So count those columns. How many were shaded in at the start of this problem?
7, like 1. 7.
How many columns in this? Look at the second square, and we're looking at the up and down columns. So I see 1, 2,
3, 4, 5.
5 columns were shaded in. So what's in your 10th place? What's going to be in your 10th place? Yes, because each column is equal to 1/10. Okay, and then how many hundredths? How many little squares after that were shaded in?
1, 2, 3, 4, 5, 6.
Mm-hmm. So that would be in your hundredths place. So then you have 1 and 56 hundredths. Now you're going to subtract. Okay, now the first thing I want you to do is count how many full columns have X's. Not how many little squares, how many columns are X'd out. Okay, with the whole column X'd out. So how many are there that have X's?
40.
Well, 40 hundredths or 4 columns, 4/10ths, right? Okay, so then what's going to be in your 10th place?
0.49.
There you go. Okay, and now check your answer.
Yeah, I got
Good
correct.
job. Good job.
Mhm.
Okay, you can go ahead and stop sharing your screen, Edwin. Thank you. Yep. You can just click that red button at the top. Okay, there we go. Perfect. Does anybody else need help? Anybody else need help? Okay, Fatima. Okay. So, oh, okay. Fatima, did you just kind of, it looks like you just wrote what Edwin and I got. Why don't you exit out of that? At like, click OK. Click OK. That little message on your screen, click OK, Fatima. Okay.
Ms. Schwab, I gotta go.
Great. Okay. Thank you, Mr. Newsome.
All right, see ya.
Miss Schwab,
Yes.
I'm still having problem on number 3.
Okay. So Fatima, why don't you share your screen real quick?
Okay. Let's see.
Hi guys, thank you all for going to work with Mr. Newsome and welcome back. Did you work on some problems with him? Some workbook problems? That's good. Okay, you got to click OK, Fatima. Okay, so you counted and you said you had, okay. So first find the whole. So we've got one whole and then how many tenths and hundredths?
2 tenths and
Uh-huh.
6 hundredths.
So 1 and 26 hundredths. Everybody else, hey guys, and then Fatima, you just need to count how many tenths and hundredths were X'd out, and that's what you're subtracting. Okay.
Okay.
So then minus, and then you're going to subtract however many tenths and hundredths are X'd out. Okay, and you don't need an extra space in there.
Okay.
All right, you can stop sharing. All right, guys, we're going to work on our quick check now. If you haven't already started, you should be working on your quick check. Okay. And that is the last thing I need from you. It's 2 questions. It's 2 questions on your quick check. And whenever you finish that quick check, you can leave for specials. If you didn't finish the practice buddy, or if you don't get a chance to finish the quick check, you can always come see me around 1 o'clock. I can help you out with your practice buddy or quick check. We can do some review if we need to.
It says it's wrong.
Okay, Fatima, let's go into the, are you still here? Okay. What did you get, Fatima? Let me see your screen again. Let me see what you typed. Okay, so let's look at what you wrote. So there was 1/10, and then how many hundredths? There was 1, 2, 3, 4, 5, 6, 7, 8. So 18 hundredths being taken away. Maybe there is supposed to be spaces after. There might have to be spaces on either side of the subtraction symbol. Did anybody else have that issue? Did
No, I
anybody
didn't have that
issue where
issue.
like, you have to have spaces? Okay, Fatima, you can stop sharing your screen. I think maybe you do have to have space on either side of the subtraction symbol. Okay, guys, it's time to go to specials. If you didn't finish your practice buddy or quick check, you need to get those done after lunch, okay? During that 1 to 2 o'clock time. All right, it is time to go to specials. All right, so let's go. If you didn't get it finished, you can finish your practice buddy or quick check later. Hey, Edwin, you were supposed to come back this morning to finish the Galileo test. You didn't come back.
Tomorrow, do I come back at 8?
Yes, come back early in the morning tomorrow. We got to get it done this week.
Okay.
Okay. All right, go to special.
Okay, bye.
Bye.